Hello, honey. Hope you sleep well after this bedtime chat. Tonight's topic is going to be about the evolution of pre-dreadnought battleships into dreadnought battleships, from basically covering the period from about 1906 when the first dreadnought type battleship was built, all the way up until the later end of World War One, and then through the beginning of World War Two. So, one of the things that I particularly want to talk about today is the large scale differences in what is a pre dreadnought and what is a dreadnought battleship. So, the term battleship has its origins going all the way back hundreds of years to the wooden line of battleship, which was the most powerful sailing ship. Now, obviously, by the time we get to the early 1900s, we're not talking about wooden sailing ships anymore. We're talking about steam powered, steel built vessels. Now, the pre dreadnought battleship emerged around the 1880s or so. It was an evolution of what was called the Monitor, and I don't really want to get into the Monitor right now, but basically, pre dreadnought battleships were on the smaller end of what we know of modern battleships. And a couple of defining design characteristics that they had. Pre dreadnought battleships tended to have, on average, four main caliber guns, usually two forward and two aft in twin turrets or twin open mountings in some pre-dreadnoughts. And those were the most powerful guns capable of penetrating the heaviest armor on an enemy ship. Now, the problem when you're talking about 1880s and 1890s technology is that those 12, 13.5 inch, some are even up to 16-inch guns, they were hard. They took a long time to reload. They were hard to aim, and because of the limited fire control technology of the day, they were pretty inaccurate. So dreadnought or pre-dreadnoughts tended to have what's called a mixed caliber main battery. So basically, you had your 13-inch guns, 12-inch guns, whatever the largest ones were, and you only had a couple of those, but those were designed to be the big hitters. But then you would have a secondary, tertiary, and even a quadrary battery of successively smaller guns. And one of the things when it comes to gun caliber is an inch in gun caliber isn't a small difference. Like a 14-inch projectile is about 1,500 pounds, and a 16-inch projectile can be close to 3,000 pounds. So there's not exactly a linear relationship between gun caliber, the diameter of the projectile, and the weight of it. So, like a 9-inch gun is a significantly smaller gun than a 12-inch gun. So, therefore, it can be faster firing and you can mount more of them. And then you might have 6 or 7-inch guns. And then you might have 3-inch guns. Because basically, it was designed to be able to protect itself from any conceivable threat. So anything from long range battleships to close range, in that era, what was known as a torpedo boat destroyer or torpedo boat, which was a small, fast craft designed with torpedoes that could sink a significantly larger ship if it got in range. So you had a lot of quick firing guns as well as some large, very powerful slow firing guns. And the theory in that era, because the fire control systems were primitive and range and battles weren't fought at very long ranges, was that the large guns would really deliver the knockout blow that penetrated the armor, knocked out the enemy ship's engines, blew up its magazines, things like that. But the significantly larger number of smaller guns were designed to, kill crew, set fires, cause flooding, basically just pepper the ship with a bunch of projectiles that, while they wouldn't actually sink the ship or destroy it necessarily, they would seriously degrade its fighting efficiency to the point where it was no longer a danger. Also, the secondary, tertiary batteries and so on were designed to fight off smaller ships as well, because you didn't necessarily need to use a 13-inch projectile to sink a very small ship. Now, what started to happen as battles began to be fought at longer ranges was eventually they figured out that when you're using the technique of spotting your shell splashes, because if you're on one ship shooting at another ship, you fire salvo projectiles. You have to see where that salvo lands, and then from there you can apply corrections to the next salvo to hopefully walk it onto your target. Now, the problem when you've got 50 guns of different calibers is if you're really up close, you can tell the difference between a 13-inch and a 6-inch shell splash. But when you're shooting at something miles away, you can't really tell the difference between a 13-inch and a 6-inch or an 8-inch or whatever anymore. So it begins to become progressively more difficult to have accurate fire control at longer ranges. Not to mention that at longer ranges, as a projectile is fired further, it loses more velocity. So it's not going to do as much damage. A smaller projectile at a longer range, if at all. That's the other thing is that as battle ranges got longer, a 3-inch gun can't shoot as far as a 8, 12, 13, whatever inch gun can. So you kind of get to the point where the smaller guns are just outmoded anyways, and they can't reach the target. Well, then one of the problems became, as the larger guns developed, they became more accurate. Fire control systems became more sophisticated and thus more accurate. Better loading mechanisms were developed that made the guns fire faster. For instance, in the 1880s, the large guns might manage one round every 4 to 5 minutes. In World War II, in the 1880s, I don't know if I said 1980s. In World War II, the American fast battleships could manage, with a well-trained crew, 2 shots per gun per minute. Times 9 guns, that's 18 projectiles of 16-inch caliber, 2,700 pounds per minute coming out of the barrels going towards the enemy. So as the main guns became more accurate and faster firing, they needed to be able to be used to a greater effect. That largely coincided with the development of better fire control, but the problem was that when you've got 50 guns of mixed calibers, a lot of space and weight is inefficiently used and eaten up by those multiple guns of intermediate calibers. So one of the principal advancements of the Dreadnought type battleship, which the name was coined by HMS Dreadnought, launched in 1906, which was the first Dreadnought type battleship, was a uniform main battery. So with Dreadnought had 12-inch main guns, but it didn't have a battery of 8-inch or 6-inch. I think its secondary battery were 4-inch guns. So that seems like a big step, but because they got rid of all the intermediate guns, they were able to use that weight, that displacement, and that deck space to add more of the larger guns. And with the advances in fire control, those larger guns could fire farther and hit things further away. So the fire control was greatly simplified because now you were only spotting the shell splashes from the one type of gun. Not to mention it simplified logistics because you're not having to have 6 different calibers on the ship that have to have their own magazines, their own supply train, own propellant charges, own spare parts, blah, blah, blah. Now, when you've got standardized calibers of everything, it makes the magazines can be stocked easier, the supply chain is easier, spare parts situation is easier, maintenance is easier, because let's say that something happens and there's a explosion that kills a bunch of your crew in turret 1. If there's a bunch of different gun calibers, it might be difficult to find somebody that can do that. But if all the guns are the same and you've got a backup crew from turret 2, you can send those guys in there after you fix the damage, and those guys will know what to do because they recognize everything. But that's a little bit getting off topic here. So that was one of the principal advancements of the Dreadnought battleship, was a uniform main battery that allowed more higher numbers of the more powerful guns, as well as more accurate gunfire. The other thing that designers began to recognize is that as armor schemes evolved, the lighter guns began to do less damage. So it was really only worth having the heaviest possible gun that could do the most possible damage, rather than having a bunch of intermediate guns that decrease in the amount of damage you can do from the large guns, while not really significantly contributing anything of their own. Another that is usually attributed to the advancement that's usually attributed to the Dreadnoughts, but is not necessarily 100% true, is the advance from reciprocating to steam turbine engines. And what that means is when you've got a reciprocating steam engine, that works like the engine in a car, where you've got a piston that's moving up and down, turning that reciprocating motion into rotational motion. Um, and reciprocating engines are fuel efficient and they're easy to make. And by this point, they were well known and reliable technology, but they also carried a lot of downsides. For one thing, reciprocating engines were difficult to make particularly powerful because horsepower is a function of RPM. So basically, more horsepower generated means you need to be able to generate a higher engine speed, which, when you're talking about a car where the pistons only weigh a couple ounces, you can spin your car engine at 6,000 RPM all day, no problem. But when you're talking about the reciprocating engines of a ship, where the piston is as tall as I am and weighs thousands of pounds, that's a lot of mass moving up and down, changing directions constantly. So at high speeds, reciprocating engines, in addition to being fairly limited on their top speeds because they weren't as powerful, they generated a lot of vibration, which was uncomfortable for the crew, hard on the ship, hard on the engines, and crucially, if the whole ship is vibrating, it makes aiming through your fire control instruments really difficult. So it hurts your gunnery effectiveness, as well as reciprocating engines really couldn't steam at full power for very long before you kind of have to ease it back a little bit to prevent damage to the engines and a mechanical breakdown. So HMS Dreadnought was not the first ship to use steam turbines. There were actually some later pre-Dreadnought designs that used steam turbines instead of reciprocating engines, but Dreadnought introduced all of these all at once. So basically, steam turbines, imagine a pinwheel in a box powered by steam rather than pistons moving up and down. They're significantly smaller. The other issue with reciprocating engines was that they took up a lot of space because they were tall, long. They could be, in some cases, 20 feet or more tall, which is a significant amount of space in a ship. Steam turbines were much smaller, and being better balanced, steam turbines, as long as they were maintained, could run at full power pretty much indefinitely, as long as you kept everything, oil in the system, cooling water supplied. A steam turbine could run flat out pretty much all the time without damage. It was also lighter, and they provided more power. And I won't really get into the dynamics of why on this one tonight. So they provided a lot of advantages, and Dreadnought was about 3 knots, which doesn't seem like a lot, but at the time it was. Dreadnought was about 3 knots faster than the next fastest battleship at that time. So, in the world that ship was born into, speed mattered a lot more than it does today. Now, some of the disadvantages of early turbines, the main one was fuel efficiency. Turbines need to run at a high rotational speed in order to be efficient. The propellers on a ship need to operate at a low rotational speed in order to be efficient. So the problem with early turbines was that early turbines were what's called direct drive, where the turbine was directly connected to the propeller shaft, and the RPM the propeller operated up at was the RPM the turbine operated at. That's not ideal for either, because it would lead to having to run the propeller at higher than optimal RPMs for propeller efficiency, and running the turbine at lower RPM than is optimal for turbine efficiency. One of the ways that you could alleviate this is by installing multiple turbine stages. So what that means is that in a normal turbine set, you've got a high pressure and a low pressure turbine, sometimes on the same shaft, sometimes on different. It depends on the arrangement of the ship. And the high pressure turbine will use the steam once, then it's passed in the low pressure turbine to where it's used again. The other issue, before I get to the efficiency, is that a reciprocating engine, by adjusting the valve timing, you can reverse the direction of a reciprocating engine. A turbine, because of the design of the blades and the nozzles, a turbine can only turn itself in one direction. So this would lead to where you would have multiple turbines on the same shaft, because you'd have a high pressure turbine, a low pressure turbine. You'd have to have a separate astern turbine in order to run the ship in reverse, because the main turbine can't turn itself backwards. And for fuel efficiency, because the turbines, like I said, were operating at outside of their optimal um, rotational speed range. There was also, on some ships, earlier direct drive ships, a separate cruising turbine of reduced power fitted that when you weren't needing to go at full speed, you would clutch in the cruising turbine and disengage the main turbines, and that would help with the fuel usage somewhat. Now, the problem with this is that by the time you get to the point where you've got 4 different turbines, plus all the piping and valves and yada yada to make it all run, even though the turbine is supposedly a much more simple unit than a reciprocating engine, by that point you've really done quite a lot to destroy the simplicity of the system, and the footprint gets really big again. So early turbines were not really a perfect solution. The solution to that didn't come till later, which is something that I'll cover in another video. But needless to say, Dreadnought, with her turbine propulsion being about 3 knots faster than the next fastest battleship of the time, was a pretty big deal. And there were still a few Dreadnought battleships. HMS Dreadnought was so revolutionary that ships built before her were deemed pre-dreadnoughts, and ships built after were deemed dreadnoughts. Because there's such a revolutionary change in how ships were built after HMS Dreadnought. So yeah, she really was quite a big upgrade. That was the 2 biggest upgrades that Dreadnought brought in that were the most visible. A couple of other things that were noteworthy, but not necessarily quite the same level of like groundbreaking, was Dreadnought was also one of the first ships that used access trunks instead of watertight doors below the waterline. And what that means is on earlier ships, even on the lowest decks of the ship that were below the waterline, you had horizontal doors that you open and close, not the same way as a house door, but think of that concept where you'd open and close a door to get between spaces. Well, the problem was that if a ship, got torpedoed or ran aground or something and ripped a giant hole in it, by the time all that water was coming in, there was nothing you could do to close those doors if they were open. So a lot of ships sank, even though even though they should have survived, because the doors were open because they weren't expecting damage. So instead of having doors between spaces forward to aft, Dreadnought pioneered the use of access trunks, which is a vertical ladder. So you had an unbroken bulkhead, an unbroken wall that separated different compartments. So what that meant was it was a little bit less convenient for the crew because you would have to go up and over the bulkhead to go to the space next door if you were deep below decks. But that also meant that you couldn't accidentally sink your ship because you weren't prepared quite as easily. Because if a space below the waterline took a hole, even if you weren't prepared for it, there wasn't an open door leading to the next one, and so on and so on, and the ship wouldn't just sink because of some minor damage. Other than that, Dreadnought was, the armor scheme was an upgrade over earlier ships, but it wasn't until the U.S. Navy's Nevada class of 1914 that really revolutionized armor. And Dreadnought wasn't particularly revolutionary in her torpedo protection either. But Dreadnought was a very interesting revolutionary ship that certainly changed with the orientation of the guns and the engines. She really fostered a revolution in how ships were built, deployed, and fought after that.